Today we're going to look at rationalising the denominator in surd, and by the end of this lesson, the learning goal for today is that by the end of this lesson you'll be able to rationalise the denominator of an expression that involves surds. So rationalising the denominator means that we're going to take any surd that was on the bottom and we're going to create an equivalent expression that will have the denominator not being a surd. So we're going to end up with a number or an expression that doesn't have any square roots on the bottom. And the way we're going to do this is we're going to make multiply by an equivalent fraction to 1 that's going to essentially multiply by on the denominator, multiply by the surd that's on the denominator to create a rational number. But for example, if it was the square root of 3 was on the denominator, if I multiply that fraction by root 3 over root 3, root 3 over root 3 is 1. It's not going to change the actual expression, but it will make the denominator root 3 times root 3, which is just 3. So that's the aim, and that's the process really. That's what we do. So for the example that we have here, we've got some value x over a surd, square root of y. If I multiply by square root of y over y, square root of y over square root of y, that is 1. That's multiplying by 1, so it doesn't actually change the value of the surd, or of the surd or of the expression at all. But what it does do is it turns the denominator from being irrational to being rational. Okay, so making sure there's no surd on the bottom. Now the reason we do this is so that it's easier to add or subtract fractions involving surds. It's very difficult to find common denominators when we're adding and subtracting surds. And to be honest, in this day and age when we've got computers, it's not so big a deal, but in the past it was very, very important when a lot of calculations needed to be done by hand or with slide rules and things like that to make it easier to see and easier to compare these different fractions. So let's have a look at performing some examples of rationalising the denominator. So for our first example here, we've got 2 over square root of 3. Now in order to rationalise the denominator, our process that we have to form is we need to multiply by a fraction that's equivalent to 1, and we need to make sure that that fraction is going to end up with a fraction on the bottom, or a number that on the bottom is going to be rational. So for this one here, we're going to multiply by root 3 over root 3. And the reason we're multiplying by root 3 over root 3 is because if I multiply the square root 3 on the bottom by the square root 3 on the bottom of the denominator of the fraction that I'm multiplying by, that will then become 3, because root 3 squared is 3. So what I'm left with here is I've got multiply the top line together, 2 times the root 3, and then root 3 times root 3 on the bottom. So I'm left with 2 root 3 on top, and root 3 times root 3 is just 3. So that's the answer that I've got. So now this expression has a rationalised denominator. It has got a denominator that doesn't have any surds in it. Looking at B now, we've got 3 root 2 over root 5. Now I'm going to multiply by root 5 over root 5, because on the bottom I've got root 5 and that's what I want to remove. So I've looked at the bottom of the expression that I want to remove the surd, the radical symbol for, turn it from a surd into a rational number. So I'm multiplying by root 5 over root 5. On the top of my expression now, I've got 3 root 2 times root 5. And then on the bottom, it's root 5 times root 5. So here, I can multiply the surds inside there together, so I get 3 times root 10 over root 5 times root 5, which is root 5. Now there's nothing I can simplify now with this expression. There's no factors of 10 that are perfect squares or anything like that, so I can't do any more with that one. It's as rationalised as they come. C, we've got 2 root 6 over 5 root 2. Now, in order to rationalise this, I don't need to multiply it by the whole of the denominator. all I need to do is multiply it by the value that's going to rationalise the denominator. So if in this case here, there's nothing to stop me multiplying it by 5 root 2, but it would be extra work that I have to do in then simplifying and cancelling. So the most simple value I can do to make sure that the denominator does become rational is just multiplying by root 2 over root 2. So on the top now I've got 2 root 6 times root 2, and on the bottom it's going to be 5 root 2 times root 2. So on the top I'm going to be left with 2 root 12 over 5 times 2, because the root 2 times root 2 is going to be 2. And then I can simplify the surd on the top now, because root 12 has a factor of, or 12 has a factor of 4, which is a perfect square. So this is going to be the same as 2 times 2 times root 3 over 10. The 10 and one of these 2's can cancel and reduce to 5. So what I'm left with, I should be working vertically, but you know, here we are, 2 root 3 over 5. So left with 2 root 3 over 5 as my simplified rationalised surd, or rational denominator surd there. Final example D here, I've got 1 minus root 3 over root 3. I'm going to multiply the top and the bottom by both by root 3. And so I'm left with now, because I've got an expression that's 1 minus root 3, I need to multiply the whole thing by root 3. So that's going to be root 3 times 1 minus root 3 over root 3 times root 3, which is expanding out the top there, is going to be root 3 minus root 3 times root 3, all over 3 now, because root 3 times root 3 is just 3. So on the top is going to be root 3 minus 3 over 3. And that is simplified and rationalised. I could have a look at simplifying further by factorising the top, but there's no common factors for the top there. Root 3 and 3 don't have any common factors. So we can't simplify that any further. That is as simple as it gets, and you can see that the denominator as well is now rational. It does not have a radical sign. So just to recap on the learning goal, today we've learned how to rationalise the denominator of an expression involving surds.